This podcast is brought to you by Scrum Gathering Canada. Learn more at scrumgathering.ca.
Hi, this is Ron Jeffries. You're listening to the Agile Uprising podcast.
Hello and welcome to the next installation of the Agile Uprising podcast. I'm your host, Ryan Locker. I am very happy to share that today's show is the triumphant return of James Grenning. James was on our show back when we were going through the Agile Manifesto author review, and he's graciously offered up some time to come back. So today we're going to dig into test-driven development, specifically James's interesting topic and interesting take on it of TDD, guided by zombies. So first and foremost, James, welcome back to the show. Thanks for coming on.
Ryan, thanks a lot for inviting me.
So in case somebody has not listened to the previous show, or they don't have a really good breadth or depth of knowledge about you, do you mind just giving a quick overview of who you are and why we should listen to you about TDD?
Yeah, sure. I'd be happy to say a couple words. So I wrote the book Test-Driven Development for Embedded C. In 1999, as a 20-year embedded systems developer, I saw Kent Beck test driving some code in JUnit, some Java, and it struck me as an important idea. And the next week at my clients, I started trying the idea with test-driven development in embedded C++, and it's evolved from there. And so I think I've been discovering, how to use it in these environments. And it struck me as a really important thing for people that usually only run their code in the execution environment. Now, I don't think this is something unique to embedded systems developers, but it is pretty true for embedded systems developers. But, if you only run your code in an Android platform, you don't run your tests somewhere else, you're missing something too. But anyway, a little bit about me. I do coaching and training, and right now I'm sitting in a hotel in Long Island, New York, talking to a friend in Philadelphia.
Well, thank you. And if anybody was fortunate enough to go up to the Agile Alliance Technical Conference, this is the same topic James covered in one of his talks while we were up there. So hopefully we get to touch on some of the things that were packed into that great presentation, and maybe we get some new nuggets as well. So as we dig in here, James, test-driven development, it's a topic that comes up quite often when I am recruiting engineers, or when I'm talking about quality practices, or when I'm talking about engineering practices. How would you go about just defining the thing that we're about to talk through? What is test-driven development in your perspective?
Well, test-driven development, when I first saw it, it was called test-first programming. And I think it was called that because in the early days, maybe the guys who started it, Kent Beck, Ward Cunningham, might not have understood the profound impact that thinking of how you're going to test something first would have on the structure of code. And so now it's called test-driven development. But the process is really quite simple in concept, and maybe more challenging in practice. But think of a test that your thing that you're working on doesn't do. If it's a brand new object, I can't even create the object. So my first test would be to create the object and make sure that it could be created. Very simple initial start. So we write a test for something that the thing we want can't do. Then we make it do that one simple thing. And then actually we make it not do that one simple thing first, which is real easy because it doesn't do it already because it doesn't exist. And it will fail its test for whatever reason, maybe because the code doesn't exist or because it executes wrong. Then you put in enough code to get it to build, but execute wrong, and then you put in enough code for it to actually execute correctly, and then you move on to the next test. So it's a very disturbing thing for new people to actually leave incomplete code. I have one new test, and it works, and it's usually testing nothing because the code to make those initial tests is not that difficult to create. I mean, aside from that, you have to not do everything you know the code has to do. And I'm saying that with emphasis.
Hmm. So when you say test, we're referring to unit test, correct?
Yeah, I'm referring to a unit test. Something usually quite simple, like, well, if I created an object, did it create? So I work a lot in C and C++. So if I created an object, could I destroy it? So in C, if I initialize something, did it do no harm? In C++, if I initialize something, does it do no harm? I use a test harness which will report things like memory leaks and such. And so just the act of creating an object and then destroying it, if I can do that without causing a memory leak or some such thing, that's considered a passing test. Very
Yeah,
small step.
I love that I loved in the first interview that we had when we talked through TDD for embedded systems, when you started talking about some of the professional experience that you've had with writing test-driven development and using that as part of your coding practices in the embedded systems world. Simply because quite often when I talk to professionals or when I'm work coaching teams and we talk about these things, and there's resistance to using TDD in Java or in Ruby or in .NET or in some of these more current languages, you get pushback because that they say it's going to slow them down, or it's a new concept. And if you're pulling this off with C and C++, there's it actually weakens the resistance from somebody in the OO languages that are trying to put up a little bit of a wall. And I might have used your name a few times when I've run into these pushbacks. So it is cool, and I think there's a great story to be had that you're making this work in the embedded systems world. So
And have been for 17 years.
that's great. And one thing I'm going to give Uncle Bob a quick nod. I know in the one talk, in one of the talks I've seen you give, you pull up Uncle Bob's 3 laws of TDD, and it's one of the more boring things is reading during a podcast. But I'm gonna take a quick stab at it. The first one being, do not write any production code unless it is to make a failing unit test pass. Do not write any more of a unit test than is sufficient to fail, and compilation failures are failures. And then the third and final is, do not write any more production code than is sufficient to pass one failing unit test. And I think Uncle Bob, first of all, you can tell the tone is Uncle Bob, but it's his simple way of just making the point very, very obvious and express the point very clearly. So I guess my reason for mentioning that, first, you have it in your deck. I imagine you had it in your presentation. I imagine that's something that you agree with, those 3 core principles of TDD.
They're very guiding, and they help you do this thing, which is I've come to appreciate this, and I wrote an article about it not too long ago. But I think a fundamental practice of programming, which no one really realizes or thinks about, is what we're doing is establishing cause and effect. Every line of code needs to do something. And so if you look at Bob's 3 rules, if you can see the establishment of cause and effect at each step. So the second rule was one that kind of throws the C programmers, because I'll write a test and I know it's going to not pass the compiler. So why don't you just go put in enough code to get it through the compiler? And I don't, because I've come to discover and appreciate that if I were to add a test case, there's a couple things that I could do wrong at that stage. Like if I forget to rename the test case, that's one error. And if I run the test right after I make a new test case and I forgot to name it, I get that error. if I'm interacting with a new function I defined, I'm expecting my build to say, hey, I've never seen this function before. What the heck is it? And so, the C compiler says it in its cryptic way, and I recognize that error. And if I get that error, I know that I'm getting the error that I want to fix next. Then I would go add that to the header file, because it is possible to write a test case and then in the header file write code that doesn't agree with that test case. And I want to get those two things in sync. So Bob says, and compilation failures count as failures. I take that to heart, and I want to get the test file and the header file in agreement. And if I'm successful at that, my success criteria is another build error, which is I can't link my program because it can't find the implementation. And then I add a skeletal implementation. So I found that that nice, concise advice of Bob's keeps me from, if I wrote all three files at once, I would have most likely sprinkled one error in each file, or one error in two files, in each of two files. And then I would start chasing my tail around trying to find them, because the compiler is so helpful when it gives you error messages. Now I have a nice simple process I follow, and I know exactly, I can relax while I'm doing it and save my energy, not for syntax errors, but save my energy for when it comes time to solve the logical problem. So I kind of work my way through syntax errors using Bob's second step, and saving, my problem-solving skills for later.
So for newer folks into the world, or into the thought process of TDD, when they hear this and they say, that just seems like a very backwards way of writing code. Why are you spending all this time writing the test up front? Why don't you start writing the code to make sure you're solving the problem?
Well, why can't you write the test? Why can't you express your requirement? I might ask back. Now, yes, sometimes that's valid though, because I can tell you about some recent experiences where I don't know what test to write, and so I'm going to commiserate with the people that say that to me.
Yeah, I think Kent Beck himself even wrote an article recently where he said if you're doing exploratory development, the test them if you don't actually know the intent of what you're looking to do. That's one use case for the to not write the test first. He said, I think he then qualified it by saying, most of the time you're not doing exploratory coding, so you should almost always still be writing the unit test.
Yeah. So I think I might have seen some of that too, and I thought, yeah, I've been experiencing that same thing. I'm working on a project. I probably was telling you about it when we went out for lunch here in Boston, but experimenting with these little radios that my brother and I think, are making a system, an industrial Internet of Things system. And to get the host little Linux box, the hub, to talk to these little radios in a mesh network, it's experimentation. What can I get to work? And once I get it to work, I want to keep it working. There's a first emphasis on how do I get it to work the way I want it to work, and then a second kind of a redo of extracting the code that I got to work into a testable architecture. Try to minimize the stuff that depends on the hardware and radio specifics, and try to enrich the objects that are about my application and make them so that they don't really depend on that radio layer, so that later, if we decide to use a different vendor, the stuff above the radio layer is reusable. I preserve that work if we discover that there's a different vendor out there I'd rather use.
So one thing that I was happy to share through my different social channels was an article a friend of mine wrote. His name's Anthony Shimana, and he was talking. He's one of these guys that was on an actual XP team in the Philadelphia region for a number of years, and it's like this unique fraternity of engineers in my backyard that I love running into in the wild. But Anthony wrote the nut of his article or his post was TDD is not a testing practice, and it's easy to make the assumption that test-driven development is a testing practice, but he posits that is not the case. And I'm curious, do you run into that, and how do you frame TDD as a practice?
Yeah, I'm sitting here smiling about that one because I would say exactly the same thing. So before people take my training class, I have them complete a survey. And one of the survey questions is, what do you like about development? And the other one is, what don't you like? And inevitably, someone will say testing. And I feel that likely it's a person that's trying to get under my skin even before we've gotten together because, their boss, the other question is, why are you coming? And they probably answered that, my boss made me come. So here's somebody going to a class whose first name is test and who's going to say, I don't like testing. And then, I'll go read that response and tell them, well, you know what? I don't like testing either. So I totally in agreement with you. But then I've got this book called Test Driven Development, and test driven development isn't about testing, even though you end up with a lot of tests. It's not about that. It's about development. So I can't really say that I'm an expert. I wouldn't say it probably about anything really. Uh, the more I think I know, the more I realize I don't know. But I would definitely agree with that. Test-driven development isn't about testing. And then I commiserate and let the person that doesn't like testing either know that, hey, we don't. Why would you want to do this testing thing, especially manual testing, repeating the same boring thing over and over and over again? Who wants to do that? Now, automating the test, that's a different story. That's fun.
Right. Yeah, you have me smiling and on this end now too because I was about a week or two ago. I was doing some internal training for my company, and we were just doing a 2 or 3 day workshop on a number of things. And usually, when I get to the area of test-driven development, specifically with teams that do not embrace unit testing and have never actually heard of TDD, there's usually pushback in the areas that I talked about. It's like it seems artificial, it seems slow. Why would you ever do that? It's backwards. And this team in St. Paul, Minnesota that I was working with, when we went through the wrap up and we talked about the things that they loved and the things that they'd rather leave behind, I was fully expecting to see TDD on the things they want to leave behind because it's a foreign concept. That was the single most upvoted thing for things that they love. So I think when we have these conversations about what TDD is and the intent behind it, the framing of that conversation is what really impacts people's perception. So I'm really happy with Anthony's article, and I'm really happy to finally start having the conversation that it is not a testing practice, even though it's called test-driven development. So,
That's right.
all right, so we're into this pretty far, and we haven't talked a single bit about zombies. And if zombies can do test-driven development, I'm pretty sure what you're going to say is the living can as well, right?
Well, the zombies actually don't do test-driven development, I don't think, but they can actually guide you through it.
All right. So all joking aside, zombies is an acronym, right?
Yeah, zombies is an acronym.
Do you mind stepping us through what it stands for and how we use that as a guiding practice?
Sure. I'll excuse me. I'll first. ZOM is an acronym that many people might have heard of. I only heard of it, I don't know, in recent history, maybe a few years ago, from a friend of mine, Tim Ottinger. I think you know him, don't you?
We know of each other. I don't know. Well, I know we've never met, but
Okay.
if anyone, first of all, Tim's going to get a mention in the show notes here, and if you're not familiar with Tim, he is a great follow on Twitter, and he's a advocate of the modern agile.
Yeah, you might want to talk to him one night too. He's a great guy. I've known Tim for quite a while. But anyway, in my book, Test Driven Development for Embedded C, I was describing this thing that I'd been using that I had seen Kent and Ron Jeffries use back in the first days when I was seeing uh, people do test first programming. And they always would start with this simplest case. And then they would make the thing a little bit, imagine you were doing some kind of collection and you would make a collection of some things that you wanted to operate on the collection. But you'd only put one thing, you'd put nothing in the collection and see what it would do if you operated on it and there was nothing in there. Then you'd put one thing in it and see what it would do. And then you'd start to generalize when you put two things in. And then later you'd add more complexity and such. And I'm writing the book and I adopted that as a way to get started, and I'd used it in many ways. simplifying the first part of a system. I actually used it in a police radio system of all things. Now I'm no longer under NDA here, but in the police radio system, we pretended like there was one police dispatcher and one policeman to get the initial architecture together. When in reality, in deployed systems, there's hundreds of dispatchers, or at least tens, and maybe thousands of police officers. We did our first architectural view, skeleton, if you will, assuming that there was one dispatcher, one policeman, to get the idea of it. That was the 0 and 1 idea of ZOM, 0, 1, many. So the acronym, there's an acronym, 0, 1, many. I was calling it 0, 1, N in my book. And then I was talking to Tim about it one day. I don't know, he came over to fly drones or something, and he goes, oh, well, that's ZOM. Oh, yeah, 0, 1, many, that's ZOM. And it's like, oh, ZOM. And I find myself talking about this in my training classes now, trying to get people to understand the application of Bob's 3 rules of TDD and why I would start with a very simple initial test case and then make a little bit less simple test case and then do some variations on those simple test cases if there's one item. I use in my article that you can find on my blog, which I know you're going to also link in the conversation here, or into the podcast. I use a C example, and I use a FIFO, a circular buffer. And if I created a circular buffer, what should I be able to ask it? Well, I could ask it if it's empty, and it would say it was. And I could ask it if it's full, and it would say it wasn't. And if I put something in, it wouldn't be empty anymore. And unless its length was 1, it wouldn't be full. And so, we could ask these questions. And so when you were dealing with the 0 and the 1 cases, the simplest cases, it gave you an excuse to create the interface for the object that you're interacting with without regard to its implementation and without the baggage the implementation might provide, which would make it difficult for you to change your mind on the API if you didn't like it once you started using it. Now, one of the cool things about test-driven development, and why you might also call it test-driven design, is that these first few test cases, the ones that are about the Z and the O, the 0 and the 1, let you explore the interface. The implementations are usually hard-coded return results, so simple that a zombie could do it. And then you get to see what it's like to use the object. And so that was really powerful. I remember watching Kent and Ron do that. Now, as I'm explaining this to C and C++ programmers, why I do that, I was noticing all these other words coming out of my mouth while I'm talking about it, like interface. These initial tests are defining interfaces. And if that wasn't important enough for them, I would say, and we've also created these test cases which define boundary conditions. And you might notice the B and the I of zombies. And as I'm writing this up on the board, a word cloud is over a couple years was forming. And then one day, it was like I was trying to work my way to zombies. And then I thought, well, when you're almost done, so now we've test-driven past 0, 1, and when you get into many, you start generalizing your design and starting to throw more realistic scenarios at it. When you think you're finished, you should step back and say, were there any exceptional things that I missed? What are the error cases I should handle? How could I abuse this thing, right? So I started thinking of other things. And the E in zombies just appeared. And in commemoration of Halloween last year, I decided to spend a couple of days and write all this stuff down and put an example, and that's where that blog came from. And finally, the S came to me because I kept saying the words simple and scenario and solutions. So you're trying to keep your solution simple while you're defining a scenario. And so it became kind of obvious to me that zombies were helping me and might help some other people to understand what you're paying attention to as you're making these choices about design.
That's great. And first, I appreciate that it while it's got a nice wrapper around it. We can say TDD, guided by zombies, and it's a fun and easy way to remember it. The backstory, I think, makes it more powerful in that the zom that came out first, and first I think it actually existed prior to you even using it.
That's right. Yeah. I had never even known it existed. I was actually looking for it. I contacted Ron Jeffries while I was writing the book and said, "This 01N thing I saw you do, does it have a name?" And he goes, "No, 01N sounds fine," or something like that. He might disavow that conversation, but that's what I remember anyway.
Right. Well, you probably softened it up a little right there too.
Okay, maybe.
But then, like, the provenance of the story, like the ZOM, the zom was kind of in use. I was gonna say it was in general use, but it was in use. And then the BI just sort of revealed itself too. So the provenance of that story is pretty impactful. So then,
yeah. So I find myself having to justify to a bunch of doubters after they just did their first experience. Why would I do it this way? You already know what code should go there. Why don't you just write the code? And I have my reasons, but that might be another whole podcast. But right, so in trying to explain it, it really helps you kind of understand it at a deeper level. If you have to take something that you just kind of see as, oh, this works, I'm going to do it, and then someone's questioning it, you have to kind of dig deep to try to find out why it's working for you, rather than it just works. Why wouldn't you do it?
So do you classify this zombies approach? Is that a framework? It feels kind of frameworky, but what label would you apply to this approach? It's sort of like a guiding principle, or maybe it's just a.
So
I apologize to put you on the spot, but
yeah, it's okay. No, it's good. So this would be, kind of the sort of thing someone would ask. You've seen how I draw the acronym. I have a vertical axis with ZOM on it. And that's kind of sequential. It's kind of a non-surprising acronym because the letters come in order. But then the BIES are not really executed in order. They're more of this is why I thought a word cloud is kind of an interesting way to envision this whole thing. So ZOM could be a linear part of the acronym, and then BIES is like a cloud because your word, while you're in, and if you want to look at this example with code, go read the article. But the Z and the O are leading me to define interfaces and catalog the behavior of the boundaries at the simplest side of the behavior of this object. The things that we always take for granted. Why would I ever have a brand new circular buffer that wasn't empty when I started it? And you would not believe how many people that test that they thought they would never need saves them in the course of the exercise. It starts failing when they don't realize that empty and full look like the same thing, depending on how you choose to implement it. But kind of interesting that it helped you define these. You declared these truths about a circular buffer in those early tests, which save you later. And you can't appreciate them the first time you write them because you're thinking, I know that code is wrong. Why don't you let me write the right code? And if I let you write the right code, you would get it wrong anyway. But not always, but many times. Let's just say 75% of the people would get that code wrong. How do you make such a claim? Well, because I watch a lot of people program, and it's at least 75%.
Yeah, so I think zombies is again, I'm not sure if it's the ZOM definitely it gives it's a linear path, so that has more of a framework feel, and then the rest is sort of like it's more emergent or expresses itself over time.
So as a software developer, what things should I be paying attention to? And boundaries, interfaces, and exceptional things are certainly things that I should be paying attention to at all times. So maybe I would think about that. Now the S kind of stands on its own and aligns with Kent Beck's rules of simple design. Keep it simple.
Right. And I think from the stance of resiliency and stability, having unit tests that at least take into consideration things like the interfaces, the boundaries, and the exceptions that are going to live on. I say this sort of loosely, but live on in perpetually, is a very strong thing to have in your arsenal. So when we talk about the feedback loops that you get from failing tests and the context savings that you get as a developer when something breaks upstream or downstream from the code that you're working on, making sure that your unit tests handle things of that nature is extremely powerful. And while we're talking about the benefits that you get at the time of writing the test, there's actually significant residual benefits in like 3 months, 6 months, 2 years later when those tests are still being run, and you're finding out that new code is causing existing code to regress. So
That's right. Yep.
yeah, so it's one of those. It's like when you're a kid and your family buys you a savings bond as a gift. It's really good to get the gift, but it's even better when you get compound interest off of it in the code.
Great.
So I have one more question
Sure.
that I sort of jotted down before we got together, and it's sort of in line with the zombies theme here, but it may be a little bit more open. So when we talk about the extreme programming practices, or family of practices, test-driven development is part of it, and so is pair programming. And I know that pairing is accepted in some teams, but what we're seeing more and more of these days are distributed teams and virtual teams. And I'm curious if you have a stance or a discussion about test-driven development in the distributed team world.
My experience there is rather limited, although we're going to have to do a shout out to Jeff Langer. He's involved in some projects with my brother's company as well. And we've been doing a bit of remote pairing, and I know he does quite a bit of it, so he would be a good guy for you to ask about. But I was kind of amazed at how effectively he and I, well, we have a good working relationship to start with. So I think, that certainly helps. And we have similar ways that we look at software and that sort of thing. But the tooling that he uses for us to pair is pretty cool. So he's using, and I'm going to get this wrong, but like VI and TMUX. Are you familiar with them?
No.
But basically, so you're going back, no IDEs and that sort of thing, because you can make kind of seamless pairing. If I type, it goes on the screen. If he types, it goes on the screen. We're basically in the same VI window. It would work really well if I knew VI, but I'm not really a VI person. So he's taught me a little bit of VI so that I, can get around the screen. But basically, we can take turns very effectively. You want to have a good microphone. You want to be able to see each other on a camera. You want to value the same things, I would expect. We value test driving. We value the conceptual design of the code. We value single responsibility. We value substitutability. There's the thing that we value and grew up with. It makes it so that we can work pretty effectively and we respect each other. So.
I think that stands for distributed teams as well as co-located teams. It makes pairing so much more impactful when there's that respect for people and there's that respect for mindset. It just makes the rhythm of the pairing so much stronger.
Yeah, and then that tooling is great. Now there's nothing like working with somebody. I don't get to do it a real lot. I get to do it when I'm with the client. Then the relationship's a little bit different. But the remote makes it, I think, generally difficult. And then I saw what Jeff was doing, and that removed a lot of the barriers. And then our relationship helped, of course. Uh, I know a lot of people go home to work because they want to get away from it all. Uh, because there's too many disruptions at work and that sort of thing. So I think if you're leaving work to get away from it, that's maybe a symptom that that maybe there's something wrong there. I don't know. I don't want to make.
Well, I think that's usually a trailing indicator of a larger issue.
Yeah, and when I get into the people issues, I like to say, hey, I'm an engineer. This is not really what I'm good at. So uh, I'd be better at solving some problem that didn't involve the people side. So I'm not as good at those.
But right.
I don't find that as ones I'm drawn to.
It is good to know the context in which you succeed or you excel. So I guess with that, any additional thoughts or anything that you want to share regarding the TDD guided by zombies, TDD in general, before we bring this to a close?
Yeah, so if there's anybody new that's out there to TDD, and if you manage to listen to this long, which might be surprising if you're new to it, um, it's interesting how helpful it is. And that one of the things I've come to realize, and I'm seeing a lot of other people saying this also now, people that are quite experienced at it, that the payback isn't all in the future. I've discovered that the payback is immediate, and maybe because I know how to do it now. Well, certainly, while there's a learning curve, and legacy code will certainly slow you down, but the initial payback, you're even when you've finished the first draft of the code and finished the tests. The amount of time you would have spent doing that is probably less than the time that you would have spent writing a first draft of the code, getting it to compile, then going off and testing it in some ad hoc way, and then having those tests be totally worthless the next time you make a change. Oops, ignoring that part, the future. At the point when we both claim we're done, I'm ahead of the game with TDD. And then later, as soon as you make the first change, if I didn't automate in scenario 2 where I was testing in some other way that didn't involve uh, a long-term commitment to having an automated test suite for the thing I built, my first change negates all the testing I did. The half-life of the manual tests is the first change. Or not the half-life, the valuable life.
Yeah, the total shelf life, yeah.
Yeah, the shelf life, that was the word I was looking at.
I got you.
But anyway, so any of you people that are thinking of getting involved in it, I would say you're going to think it's too slow. But I would say, don't dismiss it. There's people that have been doing it now for quite a while. If it was really a bad idea, they would have probably stopped by now.
It's the old adage of suspend disbelief and give it a try. So
There you go.
That's great. So, James, I appreciate the time. I know that we've made mention to a couple different resources that I'll make sure are in the show notes. But if folks want to learn a little bit more, you mentioned some trainings that I believe you make available to the public at times. How can they track you down? How can they find that?
You could go to wingman-sw.com. That stands for wingmansoftware.com. And I do TDD training a couple of different ways. The most fun is for me to come to your company and spend 3 or 4 days with your team. And then we can get into your code and everything. So that's the best thing. Typically, I'm working with C, C++ people, but I get involved in other stuff as well. And then the other thing I do is WebEx delivered versions of my training, which I can't get into your code in that way, although we could do it afterwards. It is another follow-on, but I do have technology based on this thing called Cyber Dojo that lets me monitor every move you make in your code. And so you can experience TDD, and I can watch over your work from wherever you happen to be and wherever I happen to be, and you can learn something. So if you want to get involved in it that way, it's kind of an easy way to do it. You don't have to get your whole company to commit to 15 people in a room for a week. You could just decide to send one or two.
Great. And just to pull the curtain back a hair, James and I tried to pair. Wow, how am I going to put this and not sound bad? But we tried to pair our drinking on this show. We wanted to make sure that it's an evening show, so we were both looking forward to unwinding our day with a good craft beer. And James was the first guest that we ever had on, and probably, I think so far, the only guest we've had on to share his untapped credentials. So if you're not a user of Untapped, it is a social platform to track what you and your friends are partaking in when you have a nice craft beer. So you're JW Grenning on Untapped, right?
That's right, and on Twitter.
And on Twitter. Oh yeah, we might as well plug that as well. So James, thank you so much. I'm Ryan Lockard. You can find me at AgilePHL on Twitter. If you're not yet a member of the Agile Uprising Coalition, definitely check that out. That's you can just Google that or coalition.agileuprising.com. And if you're listening to the show, please consider subscribing. Please consider giving us a review either on iTunes or Stitcher or whatever your podcasting platform is. And we hope you enjoyed it. We always love hearing feedback about these shows. So, James, one final thank you. I appreciate you spending some time with us this evening.
Thanks, Ryan. Really nice to spend some time with you, too. Thank you very much.
Hey, the place to be next spring is Canada. Our friends up north are throwing a party, a Scrum gathering to be exact. Get yourselves to Toronto for March 26th and 27th and enjoy some fun with the exchange rate. Register, sponsor, or submit a session proposal at scrumgathering.ca. The gathering will be in the heart of downtown Toronto. The nearest airports are YTZ and YYZ. Also, a special discount is available to all listeners of our podcast. Use the discount code UPRISING, all lowercase, to get 15% off the regular price of the gathering.